Hi guys. Um, this isn't going to be very long. I know I always say that, but I'm just going to introduce you to the periodic table a little bit. And the periodic table, of course, in chemistry is an enormously important thing. And I will always give you a periodic table to use on a test, or you'll always have one for use on your homework and stuff. But it is important that we know how to use it. And this is just an intro, so it's not too much info. But get your notebooks out. Let's get going. All right. This is a picture, a representation of the periodic table. First of all, these vertical columns are called groups, sometimes called families. And the elements within a group or a family tend to have similar chemical and physical properties. Now, as you might recall from last year, and I'm going to come over here and see if I can do this. Wait. The hydrogen is over here in the alkali metals, but it is not a metal. This is definitely a non-metal. And so keep that in mind. And then as we come down here, though, and we look at these alkali metals, we have lithium, which is an extremely reactive element, sodium, which is reactive, potassium, rubidium, cesium, francium, all very reactive metals, all soft metals. The groups or families have very similar properties to each other. Here we have helium, neon, and so on. These are the noble gases, all very unreactive, all gases at room temperature and pressure. Halogens, all very reactive nonmetals. So the elements in the same group have similar chemical and physical properties. Notice here that I have groups with the A's and the B's, and also 1, 2, 3, and it would all go all the way over to 18. And using the A's and B's actually is a little more informative, I think, but the newest way to do it is just with the numbers 1 through 18. So we need to know both. Then, of course, these numbers over here are periods, the rows cross, and as you go across a period, the properties of the elements vary. They are not the same like they are in a group. I know this is just review. Okay. Now, on the periodic table, if you look at your periodic table, it has certain information on it, and most periodic tables have the same kind of information, just in different places, and some have more information than others. But this is stuff you usually find on a periodic table, so let me kind of quickly go over what it all is. This is the element symbol. Now, if you recall from last year, in a symbol, the first, let me do this again, the first letter in a symbol is always capitalized. If there's any other letters in the symbol, they are always, that's supposed to be underlined, lowercase. Okay? Very, very important. The difference between I don't know, we're not going to do that. I'll just take that out. This number up here is the atomic number. This is always a whole number on the periodic table. The elements we know now, of course they weren't during Mendeleev's time, but we know now that the periodic table is in fact ordered by the atomic number, placed in order by that. And then the element name is right here. This is called the atomic mass or atomic weight, depending on what you're going to be doing with it. And this is usually not a whole number. It's a number with a decimal point in it. And that's because it's the average weighted mass of the element, which we don't really care about right now. So, okay. Parts of the periodic table. We can see here these blue elements in here. These are all metals. These down here are metals as well. Over here, the yellow and the hydrogen from over here, those are all nonmetals. These guys right here are what we call metalloids. And in actuality, aluminum is a metalloid, but lots of people don't call them aluminum metalloid because it only has a couple of non-metallic properties, and those are at very high temperature. The metalloids, of course, have properties of both metals and nonmetals. They're sort of hybrids between the two. Okay? These down here, the lanthanide and actinide series, these are actually pulled out of here. Hopefully you've already watched the crash course on periodic table and you know all about that. Writing chemical formulas. Again, I know this is all review. Basically, when you're writing a formula for a compound, and what exactly is the difference between an element and a compound? Think about that. And if you can't answer that, go back and figure it out. When writing formulas for compounds, the symbol for each element is written with no spaces. The fact that there's no spaces here indicates that, in fact, these two elements are bonded together. This is sodium Na and chlorine Cl. The total number of atoms in the formula, of course, and then let me go down here. The total number of atoms in the formula here are 2, because the symbol all by itself with nothing else is represents 1 atom of that element. And then we have the total number of sodium atoms is 1. Well, that's a 1. Just a sec. Makes me crazy. No, go back to where you're going. All right, so here we have 1. And here we have 1. Okay? If you look at the total number of atoms of each element in the formula, that has to add up to the total number of atoms in the formula. Now, if there's more than 1 atom of a particular element, the number of atoms of that element is indicated with a subscript after capital letters, after the symbol. For example, and now I have to go back and get my pen again. K3N. This 3 tells me that there are 3 potassium atoms in this formula of potassium nitride. Okay? Being as there's no subscript here, that's indicative of a 1. There's just 1 of those atoms. So here, get all those out there so that my pen will work better. The total number of atoms in this formula is 4. We have the 3 here and 1 here. There are 3 potassium atoms, and there's 1 nitrogen atom. Okay? Oops. So pause and complete this table in your notebook, guys, and then come back. We have 3 formulas here. I want you to put the total number of atoms in the formula and then the number of atoms for the first element and then the second element. Okay, pause for a few minutes or for a few seconds and do that and come on back. Okay, guys, hopefully you've all done that by now. Let's go ahead and look at BAS first. And notice, by the way, the A is lowercase and the B is capitalized, indicating that this is just one atom of one element, okay? And down here, well, we have chlorine, which again is one atom of one element because we have this is uppercase and this is lowercase, and calcium and aluminum, all of them the same. And so total number of atoms here is 2 because there's no subscripts, and so that's indicative of a 1. So there's 1 here and there's 1 here. Notice these both have to add up to 2. Here we have no subscript by the calcium, so that's a 1. There's 1 calcium atom, and ion actually, but we'll call them atoms for now. And then here there's a subscript 2, so there's 2 chlorines. And so there's a total of 3. And then over here we have 1 calcium, and we have 2 of the chlorine. Here we have aluminum and oxygen. And again, notice this is Al, and the L is lowercase. The A has to be capital. And there's 2 of these and 3 of these, so altogether there's, oops, sorry, 5 atoms altogether, and there's 2 here and 3 here. Does that make sense? Okay, now make and complete the following table in your notebook and bring it to class for me to check. And obviously you need to pause to do that, and then come on back. Oh, I guess we're done. See you in class. Let me know if you have any questions.